Hello everybody, I'm Nikita Irumin and we continue our Python lectures. Let's talk about some powerful concepts allowing us to write really cool, bug-free to some extent, and maintainable code. These concepts are decomposition and abstraction. In order to benefit from using it, programming languages provide us several syntax constructions. One of them is called function. We already know how to write code and solve some computational problems. And up to this moment, all the code we considered was fit in one page stored in a single file on disk. That's handy when you deal with simple tasks, but when complexity grows, you can end up with really huge, unmaintainable programs if trying to keep everything in one place. It's really hard to keep track of details and, in the end of the day, makes our code buggy. It's clear now, more code is not necessarily a good thing. So what do we call a good programming? If you can write less code and provide more functionality with it, you are definitely a good programmer. So what do good programmers do to divide and conquer the complexity of larger scale programs? The key word here is divide. When you split code into different files or even somehow separate it in a single file, avoid duplication and make common functionality reusable, you are going the right way. One of the ways to achieve this is using functions. Function is a programming language syntax construction allowing to separate logically united code, typically doing some single thing. To understand this better, let's consider a real-world example. Imagine you have a projector. For a general user, it's a so-called black box. Typical projector user doesn't know what the internal implementation of it is, and he or she doesn't know how it works. It's enough for a user just to know the interface. How should we connect the input to it, and how can we see the output? So here's an abstraction idea. We don't need to know how projector works to use it. Now let's imagine we have an interesting task. Project a large image for an Olympic Games ceremony. We don't have a really huge projector capable to do this, but we have a bunch of smaller projectors. So we could split the image into parts and feed each part into a single projector so all projectors could work together to produce a larger image. Now you've got the decomposition idea. Different devices work together to achieve an end goal. Now we understand what decomposition and abstraction is in real world. Let's apply it to programming. In our example with projector, we separated devices so each could do its part of the job. In programming, the idea is to divide code into modules. Usually each module is a separate file. It can be reused from different parts of one or many applications. This approach helps to keep your code organized and coherent. Cohesion is a measure of how strongly related and focused the various responsibilities of software modules are. High cohesion helps to write robust, reliable, reusable, and understandable code, whereas low cohesion is associated with undesirable traits such as being difficult to maintain, difficult to test, difficult to reuse, and even difficult to understand. Now, let's see how an abstraction concept can be applied to programming. In our projector example, instructions for how to use it were sufficient. We don't need to know how to build one to use it. In programming, you can think of a piece of code as a black box. One possible approach to implement it in Python is using functions and docstrings. So, how can we create a function in Python? First, think of it as a piece of or chunk of code which can be reused. This is done by calling, or in other words, invoking a function in your program. Let's see by example what parts of function consists of. Usually function should have a name. A good practice is selecting a name giving a good understanding what the function does. In our example, function name is even clearly identifies it checks a number is even or not. Function can have parameters, 0 or more. In our example, the function expects one param to be passed. Recommended practice is creating a docstring for a function. It will allow function users to easily understand what kind of params function expects and what the result returned. So, as you can see, our isEven function expects a positive integer input and returns true in case it's even and false otherwise. Main part of the function is its body. That's where the code doing the work lives. Usually functions return some result, but that's optional. In case there is no result, a function returns non-type. Later, in the code, you can call the function using its name and values for params. Let's have a closer look to the code inside our function body. You can see a statement printing a message to console. You can use it to log your script execution, or sometimes it can be used for debugging. Next goes expression calculation. We get the remainder from division our input param by 2 and checking if it's equal to 0. The result of comparison is returned as function output. Now you have a handy routine allowing you to check easily if any number is even in just one line of code. Obviously, in real use case, functions can implement much more complex logic. Though it's recommended to keep function body lean, it's a good practice function code fits on a screen so you don't have to scroll it. Now we got to a very important concept of a variable scope. First thing we need to mention here, params specified in the function definitions are called formal parameters, and values of variables passed when calling a function are actual params. When a function is executed, a special environment is created called scope. Variables defined in the scope belong to it and can be accessed outside of it. Let's try a simple example of the function f accepting a formal param x, increasing its value by 1, printing some output and returning a new x value as function result. When the function is called, we have two scopes existing in our program in parallel. First is the global scope available all the time our script is running, and the second is our function scope created when we call the function and available during function execution. We have passed a number of 3 as a param for our function, so when function scope is created, variable x has a value of 3, both in global scope and in function scope. In fact, these are 2 different variables, just sharing the same name. During the function execution, value of x inside function scope changes to 4. When function completes, the result is returned back to the global scope and assigned to variable that. Note, the value of x still remains 3 in global scope. Finally, function scope is removed from memory and the only scope left is global scope. Function arguments can take on any type, even functions. There are 3 functions in our next example. Func A accepts no arguments, func B accepts 1 and returns it back, and func C accepts a single param and does interesting thing. It tries to invoke whatever is passed in and returns the result of the invocation. Let's see this in action. Func A does not return any result, and none is returned to the global scope. When we pass 2 as a param to func B, it returns its back. So when a second statement is executed and we add the result to 5, the total is 7. Let's see what's going on when we call func C and pass func A as a param to it. First, func C scope is created. It calls func A, and it also creates new scope. Func A returns none, so the result is passed to func C scope and in turn passed to global scope from it. Here's one more scope example. As a note, inside a function, you can access a variable defined outside of it, but you can't modify its value in the outer scope. One exception to this rule is using global variables. If you define a variable as global, you can modify it from inner scope. However, extensive usage of global variables is not recommended. So now we see how decomposition and abstraction applied with functions can be powerful in creating code you can debug only once and use it as many times as you need.